So as the title suggests, we are going to be doing some visualizations with RNeo4j. And no worries if you're not familiar with either of these things. We're going to start pretty slowly and then move into some visualizations. So let's look at the agenda. These are the R packages that I'll be going through today. So the first one is RNeo4j. That's the package I wrote that allows you to talk to Neo4j from R. So we'll be writing queries and getting our results into R through that package. And then the next three packages are the visualization packages we'll be looking at. So igraph is actually much more than a visualization package. It's a full graph algorithms package, but we'll be looking at the visualization side of things in igraph. And then we'll look at D3Network, which is a wrapper around D3JS. And we'll look at some interactive visualizations there. And then vizNetwork is a wrapper around, I think, vizJS, another interactive visualization library. And then we'll look at Shiny, where we'll make a user interactive visualization where we have user input into the visualization. So this is sort of, at least within the three visualization packages, igraph, D3, and viz, sort of, in my personal opinion, from good, better, best in terms of visualizations. And it should be noted that igraph, like I said, is much more than a visualization library, but in terms of just the visualization side of things, I'd say it's just average. So we first need to look at the data set that we'll be using today. So for a few hours yesterday, I collected tweets, some Twitter data that was related to the hashtag #rstats, and stored it in Neo4j. So if you don't know what Neo4j is, here it is in a nutshell. You have nodes and relationships, and you have different types of nodes. So here up in the browser, I have a hashtag node, a tweet node, and a user node. And then we have different relationship types between these nodes. So you can see we have users. So here this user, Alex Bresso, posted this tweet. And all of these nodes, if you're looking at the bottom of the screen, have properties on them. So this node has a username property. It's a user node with a username property. This is a tweet node. It has a unique ID. It has a text property, the text of the tweet. And you can see that we have a few other relationships going on. So we have the user posting the tweet. We see that the hashtag #rstats tags this tweet. And this tweet mentions these three users. It mentions, I think this guy's name is Bob, and then the Tau Charts user, Timely Portfolio. And then we have the hashtag #rstats tagging that tweet. And then, of course, within the tweets, between the tweets, we could have tweets retweeting other tweets, so on and so forth. So then here we see Hadley posted a tweet. And then this user posted a tweet that retweets this tweet and mentions Hadley. So a pretty complex, highly connected data set, but with Neo4j, it's pretty easy to store this kind of information. So long story short, we're mostly going to be using the user posting tweets relationship and the hashtags tagging tweets relationship, and we'll also be looking at the mentioned relationship later on. But this is our data model in a nutshell, and my quick 20-second, what is Neo4j? It is nodes, different nodes with different types of relationships between them, where these nodes and relationships can have properties on them. So for example, the hashtag node has a name property, the name of the hashtag. So that's the data set that we're working with these visualizations that we're going to get into right now. So the first thing we need to do is start the RNeo4j package, which you can start with library RNeo4j. And then we need to connect to the currently running Neo4j database. And so this is the URL of my database. This is the default. So we usually don't need to change this. And we do that with start graph, and that'll give us a graph object. Then we can pass that graph object to the summary function in RNeo4j to get an overview of what our graph looks like. So we just look at this visually, but sometimes it's nice if you forget what your model looks like, or the name of a node or the name of a relationship. You can look at this. So this is all the combinations of node, relationship, node that exist in our database. So as we saw earlier, we have hashtags, tags, tweets, user, post tweet, tweet mentions user, so on and so forth. So it's a nice, easy way to familiarize yourself with your data model. So that is how you get RNeo4j up and running. And then there are a ton of functions within RNeo4j, but the one we need today is just the Cypher function, which will allow us to retrieve Cypher query results into a R data frame. And so this is our first look at Cypher. We'll be using Cypher throughout to extract what I like to call subgraphs out of our full Neo4j graph for further study and analysis within R for visualization purposes. So this is a first look at a Cypher query. We have our match clause where you essentially draw out the graph pattern you're looking for. So you draw nodes within parentheses, you draw relationships within square brackets, and then you can draw the relationship direction with hyphens and arrows. So here we're matching on a tweet node. You can specify which type of node you want with the colon label. You can specify which type of relationship you want with colon relationship type. So here we're matching on tweets with outgoing mentions relationships to a user node. And then we put an identifier u here on this user node. It's just a variable that we can refer to later in the return clause. And then we're getting that username property off of the user node and counting how many times that this pattern has occurred as the number of times that user has been mentioned by a tweet. And then we're ordering by that count descending, limiting 5. And then to pass this query to Neo4j, we use this Cypher function within RNeo4j, where the first thing we pass is that graph object we created in the previous slide, and then the query. And then the output is a data frame with the column names as whatever you alias them up here in the return clause. So here we have a u.username column, and then we have a mentions column, and that's the name of the columns here in the data frame. So that's all we really need to know about RNeo4j, is how to connect to the graph with start graph, and then use the Cypher function to write queries and get results into a data frame. So these are the top 5 mentioned users in the database. So let's look at our first package. We're going to look at igraph first. We're going to first look at its visualization capabilities, and then we're going to look at its graph algorithm, graph metric capabilities that we'll be using within igraph visualizations themselves. And then also later, when we get into the other packages, we'll still be using igraph because we want to use igraph to get the cluster assignments when we do community detection, and then we want to size the nodes by different metrics and so on and so forth. So we'll get into that later. But for the visualization side of things, of course, we first need to load igraph with library igraph. And then a common theme that you'll see throughout this presentation is that we'll be extracting edge lists with Cypher queries, because all of these packages, igraph, D3Network, visNetwork, expect or can work with edge lists to create the relevant objects needed to create the visualizations. And edge list is node 1, node 2 in 2 different columns, indicating that there should be an edge between those 2 nodes. So in this particular query, we're extracting an edge list of hashtags that have mutually tagged a tweet. So in this query, in the match clause up here, we have a hashtag H1 that tags a tweet, and then we're getting another hashtag, an H2 hashtag, that tags the same tweet. So H1 and H2, these are just identifiers, so we're matching on all mutual hashtag co-occurrences, and we're omitting our stats because it's everywhere. Almost every tweet is tagged with our stats because it's what I searched on when I crawled Twitter. So we're just saying that the H1 name can't be our stats and H2 name can't be our stats. And then here, finally, in the return clause, we're getting an edge list of all these occurrences. We're getting the name of the first hashtag, the name of the second hashtag, and then we're counting how many times that occurred as the weight, because in igraph you can weight edge lists, and then that will be taken into account when you do, for example, centrality measures or clustering algorithms. So here's our query. It's going to give us an edge list much like this. So we can pass the graph object first to the Cypher function, and then the query we just wrote, and then we're assigning that to a data frame called edges. So this is the first 6 rows of our edges data frame. We have our H1 name column, H2 name column, and the weight column. So this is, again, indicates that an edge should exist between these 2 nodes. So in this subgraph that we've extracted out, we only have hashtags, and they're connected if they've ever mutually tagged a tweet, and they're connected by a weight of how many times that happened. So Python and Hadoop have been used once together in a tweet. Hadoop and Big Data twice. Big Data and Data Science 7 times. So this is our edge list that we'll be using for a few of the visualizations. So we can easily plot this with igraph. We can read the edge list into igraph with graph from data frame. So graph from data frame is an igraph function that takes an edge list, just like the one we just extracted out of RNeo4j with the Cypher query. And then we can pass that igraph object to plot. So here we have graph from data frame, where we're passing that edges data frame we just created, and we're saying it's an undirected graph, so directed is false. And then you can plot with the default settings just by passing that igraph object to plot. And here is the default igraph plot. It's not too visually pleasing. The default color is kind of nasty, and then they have text everywhere, so it's kind of hard to really see what's going on here. So usually when I'm plotting an igraph, I usually remove the vertex label because I'm usually just plotting it to get a vague general idea of what my graph looks like. You know, do I have a giant one connected component? Do I have a lot of tiny disconnected components? It's just usually to get an overall idea of what the structure of my graph is. So usually I'll first pick a less disgusting color and assign that to vertex color, and then I'll set the labels to NA. So here we're, again, just passing the igraph object to plot, but we're setting some options. And here we get a nice, at least what I think is a nicer picture of what our graph looks like. And at this point, I don't really care about the labels. We'll get into the labeling the vertices when we get into some nicer visualization tools. Of course, you could mess with moving the text around in igraph. You can offset it and write some fancy algorithms to offset the text so that they don't overlap, but I don't think it's worth the effort when there's other visualization packages that will do a better job. So this is what our graph looks like. Remember that each node is a hashtag, and they're connected if they've ever mutually tagged a tweet. So this graph was inferred out of the full RNeo4j graph. It's just a subgraph that we've inferred out with a Cypher query. So now let's look at getting some insights into our graph using some of the algorithms in igraph, the centrality measures and clustering and whatnot, and then incorporate this information into the visualization. So here, we're using the igraph function betweenness to get the betweenness measure of each node, and then we're just sorting it by decreasing and showing you the top 5. So again, this is the igraph object that I'm passing to igraph's betweenness function, and I'm sorting it and giving you the top 5. And so these are our top 5 nodes, hashtag nodes by betweenness. And betweenness is a measure of how often the node is on any shortest path. So the betweenness algorithm, it finds all shortest paths between every single combination of node in the graph, and then counts how many times that node is on a shortest path. So it's a measure of a node's betweenness. So nodes with high betweenness usually are bridging clusters or communities in the graph. So data science, Python, big data all have very high betweenness, at least in this particular graph. This was, this data was only collected over a few hours yesterday, so it's just a snapshot in time. All right, so it's pretty easy using the plot method here in igraph. We have the same vertex color and vertex label settings, but now we're setting the vertex size equal to this betweenness measure that we calculated, and I'm scaling it a little bit here, dividing by the max, because otherwise we get these giant nodes that fill up the entire slide. But it's just an interesting way to very quickly and easily get an idea of what your graph looks like when you scale the nodes by the betweenness. Do we have just one giant node that's that's bridging two communities? Do we have a few nodes that's bridging several communities? So here we see that we have about 3 nodes that are bridging communities here, but it's not very insightful yet because we don't have vertex labels, because it's kind of a mess in igraph when you label your nodes. And like I said, we also want to look at the community detection algorithms within igraph. And this is very, very easy. They have the built-in, they have cluster edge betweenness, which is just one of the community detection algorithms out of several. It uses the Girvin-Newman algorithm, which is a very fun algorithm that you should read about on Wikipedia. Essentially, it will iteratively remove edges with high betweenness centrality, and then what's left is the clusters. So we're just passing that igraph object to cluster edge betweenness, and then we get this list called clusters. I've assigned it to a variable called clusters, and it's a list of all the clusters. So here I'm just showing the first 3. So we see that Python, Hadoop, Spark, Big Data all ended up in cluster number 1. Digital Humanities, DH, which I'm guessing are synonyms, ended up in cluster 2. Data Science London, Earl 2015, maybe that's a conference going on right now, ended up in cluster 3. So there's several clusters, either just the first 3. So the community detection algorithm iteratively removed those edges, and then what was left were these clusters of hashtags that are commonly used together. From that point, it's very, very easy to then, within igraph, color your nodes by this cluster membership. So previously, I was just setting all colors to cyan, but here we're now setting the vertex color to the membership of that clusters list. So now all the nodes are colored by their cluster membership, and now we can get a visual representation of what our clusters look like. We have, of course, all of our disconnected components are in their own cluster, but then within this bigger component, we see that we have 3 clusters going on here. But we'll look at a visualization later where we can actually have node labels on this and see what's going on. And this is where D3Network is going to come into play. So D3Network you can install with install packages, and you can load with library D3Network. And again, this is a wrapper around D3.js. And we can actually just pass that edges data frame that we extracted out earlier. So if you recall, we wrote that Cypher query to get the edge list of hashtags, and we assigned it to a data frame called edges. With D3 Simple Network, at least, so this is a function within the D3Network package, we can just pass that edges data frame, and it'll create the interactive graph for us. So this is an interactive D3.js graph, and we can see that we have the node labels now. And they still overlap, but I think it's much easier to read, and you can actually move them around, and so you can see the text and see what's going on here. So I think these interactive visualizations are a bit nicer for figuring out what's going on in your graph, especially if you want to display node labels. I think it's a bit nicer. So here's our graph, the same graph we've been working with, but instead we have it in a D3 graph. And we were able to pass that same edges data frame to D3 Simple Network to get this result. The downside of this D3 Simple Network is that you can't color the nodes differently, as far as I'm aware. I looked pretty heavily at the source code, and I don't think you can do that. And there's also this weird, if you click on it, the text will get really big and red, and then you can't make it go away. So there's some pros and cons with this D3 network package, but it's very easy to do because you can just pass the edges data frame to this D3 Simple Network function. D3 Force Network, on the other hand, is not as easy to use. It requires a bit of data cleaning, reformatting. So we have the D3 Force Network function within D3 Network, and it requires both a nodes data frame and an edges data frame. So previously, we were able to just pass the edges data frame, the edge list, and it would get the nodes out for us. We didn't have to do any work. In this case, in vPorce network, for some reason they require you to pass both a node data frame and an edges data frame, but it's not a big deal. All you have to do is get those unique values out of the edges data frame. So remember, our edges data frame had these from and to columns, the source and target, the H1 name and the H2 name, the two nodes that were connected. And here we're just passing those values through unique to only get the unique values, and then we're saying the column name is the name, and then we run a data frame. So in one line, we can get this nodes data frame, so not a huge deal. Here in this data frame, we just have one column, the name column, and these are the names of all of our nodes. An especially annoying thing about vPorce network, though, is that the edge list at this point it can't point to the name of the node in the nodes data frame. It has to point to the position of the node, the indexed position. So essentially here, I'm iterating through each row of this edges data frame, getting the name of the from and to columns, and then finding the index of that name in the nodes data frame, and setting that as a source and target column. So this is getting the which function here is telling us the index in the nodes data frame that name occurred, because the edge list now needs to have an index to the position of the nodes data frame. So long story short, we get something like this. I should also mention that despite the rest of the R world using indexes that start at 1, the vPorce network function wants your indexes to start at 0. So subtract 1 from both of these columns. And then we have an edges data frame that looks like this, where this is our original edge list, H1 name, H2 name, that we got with Cypher in the wiki. These are our two new columns, source and target, that are referring to the n-1 position of the node in the nodes data frame. So now we just have these numeric positions, the index positions. So after that, it wasn't actually too bad. There's just a few lines of code of cleaning there to get this information. We can now pass it to vPorce network. So we have to pass the edges data frame, the nodes data frame. We have to tell it the name of the columns in the edges data frame that have the source and target nodes. And here's our graph. So in vPorce network, the names do not display by default. You hover over them, and you can see them. And then the colors are random. They just have random colors there. But we can color these by something more insightful and more meaningful by using that cluster assignment that we got out earlier with igraph. So this is I would say, the downside of vPorce network is that you have to hover over it to see the names. Whereas in vSimple network, the names were visible, but if you ever clicked on anything, they got really big and red and never went back to their original size. So again, pros and cons with this package, but it is pretty easy to use and easy to make these really quick visualizations. And like I said, the colors in the previous visualization were random, but we want to color the nodes by the cluster assignment that we got earlier. So remember, we used igraph to get this clusters list. And all we need to do is add a group column to this nodes data frame, indicating the cluster assignment each node had. So here, Python, Hadoop, Spark, Data all ended up in group 1 in cluster number 1, and then Digital Humanities is in cluster number 2. So throughout the data frame, there's a group column indicating which cluster the node is in. Then from that point, we can actually very easily, within vPorce network, we have all the same settings, except now we're telling it that the group is, the coloring, it can be found in the group column of the nodes data frame. So now our nodes are colored by cluster assignments. So you can see that big data, Boston, Earl, all ended up in one cluster. Analytics, data viz, here's data science, and then here's a few clusters out there on their own. So this is an okay graph. I mean, it's still kind of annoying that you have to hover over each node to see the names, but it's pretty visually pleasing, and it's a nice way to visualize your clusters in an interactive way. Now, onto my favorite visualization library in R. It's a relatively new package, I think still in version 0 point something, and you can install it with install packages, vizNetwork. It's a wrapper, I believe, around the viz.js library, and you can load that with library vizNetwork. So for the sake of variety, we're going to abandon our hashtag graph. So we've been using the same edge list for the last few slides. We had that hashtag graph that we inferred out of the full Neo4j graph. But for the sake of variety, let's go to a different edge list, and let's say we're interested in users mentioning other users in our Neo4j graph. So if you remember, over here, users can post tweets, and these tweets can mention other users. So this pattern will exist several times in our graph. And we can extract this out very easily with a Cypher query. So let's say we now want an edge list of users, and these users are connected if they've mentioned, if the from user has mentioned the to user. So the match clause is fairly straightforward. We're matching on a user that has an outgoing post relationship to a tweet, and that tweet has an outgoing mentions relationship to another user. So now in the return clause, we're just returning this edge list. We're returning the username of the first user as from, the username of the second user as to, and then the count of how many times that happened as weight. And we want the weight because we'll eventually be putting this in igraph, and igraph will use the weights in its clustering algorithms. But the column names are important here because visNetwork, out of the box, it expects your column names to be called from and to in the edge list. So here we're aliasing it as from, aliasing this as to, and then of course we can just pass this query through the Cypher function in RNeo4j, and we get an edges data frame. So this is the first few rows of our edges data frame. So we see that Adam Slez mentioned Hadley Wickham 1 time. S. Jackman mentioned Hadley Wickham 3 times. And so that is what this edge list means. These are users that will be connected by edges in our graph from now on. It's important to note, I think, that this edge doesn't exist explicitly in Neo4j. We don't have, there's nothing between these two users in Neo4j. We only have that this guy posted a tweet and it mentioned Hadley. There's nothing, there's no edge between them in Neo4j because it's not necessary, it's not part of our model. But with Cypher, it's really easy to infer that connection out and get an edge list where we can actually create a graph in R where that edge does exist. So vizNetwork requires a nodes data frame in addition to the edges data frame. But like I said, that's easy to do. We're just going to get the unique values out of the 2 columns in the edges data frame. We have that from column of nodes, we have the to column of nodes, and we're just passing that through unique to get the unique values. So now we have a nodes data frame that looks like this, and the column name is important. Actually, throughout the rest of this using vizNetwork, the column name is important because it's the column name that vizNetwork looks for when doing different visualization things in the graph. So we need an ID column, and this ID column must refer to the from and to columns in the edges data frame. So in the from and to columns of the edges data frame, we have the usernames. So the ID column of the nodes data frame must refer to those names. So whatever you have in the from and to columns of the edges data frame, it must match what you have here in the ID column. Another column you need in the vizNetwork side of things is a label column. So the ID column is just for referring to that edges data frame, but the label column is actually going to be what it labels the node as in the visualization. So these could be different if you wanted them to be, but in this case, it's not necessary. They're just going to be the same. The label of the node is the same as the ID of the node. So here we're just setting the label column equal to the ID column. So now we have this nodes data frame with 2 identical columns, node named ID and label. And then it's quite simple to pass this to vizNetwork. So to create a visualization in vizNetwork, you pass the nodes data frame and the edges data frame. And this is what you get out of the box without any options set. So when you're zoomed out very far, you don't have any node labels. And then once you zoom in, further, it starts to slowly show you the names. And I think this is the best visualization because it's very crisp. You can see the names very easily. You can move the graph around. Clicking on white space moves the graph around very nicely. It's just a pleasant way to visualize and explore what you have going on. So remember that this is users mentioning other users. Two users are connected if they've ever mentioned each other. So you can see Revolution R has mentioned himself apparently. And right, so I just think this is a very nice way to explore your graph. Here's everyone mentioning Hadley. I think there's a group of us. Yeah, so here's me and my RNeo4j crew. There's Christopher, RNeo4j, Kenny, Carl. And of course, there's some people out on their own over here. But just a really easy, pleasant way to visualize your graph. And it was just a few steps. We wrote a Cypher query, we extracted out our nodes data frame, and here we are with a very nice visualization. But this is the out of the box. It's everything blue. We haven't really set any options yet or done anything too insightful. So let's actually go back to igraph to gather some insights and supplement the visualization with a clustering algorithm, coloring the nodes by the clusters that they get assigned to. So we're going to do the same thing that we did earlier, where we can pass the edges data frame that we already have to graph from data frame. So IG will be an igraph object, and then this graph is going to be directed because it's users mentioning users, so there is direction here. And so we're going to say directed is true. And now we have this igraph object. And then the same thing, we're going to use edge between this clustering to get cluster assignments. Here we have 38 clusters apparently, so this is a list of cluster assignments. Again, we see cluster edge between this, so we pass that igraph object. And then vizNetwork, if you have a group column in your nodes data frame, that it will color the nodes by their grouping. So it's very easy to do this. We're going to say that the group column is equal to the membership of that clusters list. So you can see that Adam, this person, all ended up in group number 1. Leah ended up in group number 2. This guy, group number 3. And so on and so forth throughout the data frame. So now we have our group assignments for our clusters, and that was just a couple of lines, which I think is pretty awesome. So now, because we have that group column in the nodes data frame, we can still just pass it to vizNetwork like this, and now our nodes are colored by their cluster assignments. So you can see we have a big light blue cluster here, and then down here we have a purple cluster. Here's ecology. Podcast. Here's our open sci. Over here we have all of the keys. I think this guy's name is Bob. Talking about tau charts. Here's Alex. So you have a cluster of people mentioning each other here, a cluster of people mentioning each other here, with a big cluster here, and then here's me and my RNeo4j people. All of them didn't make the cut into the RNeo4j cluster. But yeah, and then all of our disconnected components over here are setting their own clusters. So very, very easy, just a few lines to get this kind of information into your visualization. I think it looks pretty good, and it's very possible that it had to recycle some colors, like it probably recycled purple and pink. So these two nodes are not in the same cluster, but I'm sure it just recycles colors as it runs out of them. So if you have separate clusters over here, it just recycles them. And the last thing I want to do within vizNetwork is make the node sizes a function of their betweenness. So we already did this in igraph when we were making visualizations back in igraph, where we pass the igraph object to the betweenness function. This is an igraph function, betweenness. But in vizNetwork, if you have a value column in the nodes data frame, it's going to size the node by that value. So now we're assigning the value column to this metric as determined by igraph, and now our nodes data frame looks like this, where it has a value column with the betweenness measure of the node. So we can always, look at this just in a table. So here I'm showing you, just like I did in igraph, the top 5 users by betweenness. where again, betweenness measures, like the name suggests, they're betweenness between communities because it's going to count how many shortest paths they're on. And so these are the users that are bridging communities. So here we have, I believe, Bob, Oliver, Alex, Logo, I don't know. And so this is nice because it tells us who the top users are, but it doesn't give us a lot of context about what are the communities that they're bridging. Whereas if you incorporate that information into a visualization, you get a lot more context into what's going on. So we can actually see from the visualization, here's 3 big nodes, here's 3 big betweenness people in our graph. So let's zoom in and see what's going on. So here we see Oliver is bridging these 2 communities between this open side purple community versus this orange community over here, couch arts and whatever they're talking about over here. And so you can see that this node is big because it's going to be on a lot of shortest paths because of it's one of the few nodes that are bridging these 2 communities. So same for this node right here. It's the only node actually bridging this big community up here with this community down here. So it's going to have a very high betweenness measure. And same with this node, it's the only node that's bridging this whole thing over here and this thing over here. So we have high betweenness. And then I have a slightly elevated betweenness because I'm bridging between this RNeo4j topic over here with the rest of the R community. And of course, all of these disconnected components are going to have 0 betweenness for the most part. So those are all going to be small nodes. So it's very fun, easy, simple, pretty to visualize this kind of stuff within vizNetwork. And lastly, I want to quickly build an interactive tool for visualizing hashtags. And you can do this with Shiny. And I'm just going to do a really, really simple one. And so we're going to go back into hashtag mode, where we're going to get hashtags mutually tagging tweets. So this is the same query we looked at earlier, where the first hashtag is going to be some input by the user. And here we're using parameters within Cypher. This is a parameter because it's wrapped in curly braces. I like to call them named parameters. So when we run this query, we're going to have to pass a hashtag parameter. And that's going to be some user input. And then we're just going to return the edge list like we've been doing the whole time. The from node, the 2 nodes, so h1 name, h2 name, and then the count as value. And we're actually going to be weighting the edges by this. We're going to be, at least in the visualization, the edge width will be this value. And right, so making a Shiny app is super, super easy with the built-in stuff here. So we can make a text input box for the user to fill in. It's going to be called hashtag. So this is actually the name that you refer to the input later. So that's actually what we're referring to right here. A label, and then a default value is going to be Python. So by default, we'll be looking at the Python hashtag. And then visNetwork, very conveniently, ships with render visNetwork, which will, if you end the function with visNetwork, it's going to render the visual network for you. So the same thing here. We're going to get an edges data frame with the Cypher query. We're passing the graph and the query. And then these are the 2 mandatory arguments to Cypher. We have to pass the graph object, the query, and then the rest are key value pairs for any parameters that the query expects. So remember that the query expects a hashtag parameter. So that's what we're doing here. We're saying that the hashtag is equal to the input hashtag, which again, this is referring to this right here. And then the same thing where we're getting our nodes data frame by only getting the unique values out of that edge list. And then we want to label the nodes, and it's the same as the ID. And then we can pass that to visNetwork. And I actually have to jump out of the slides for this. I couldn't get it to work in the slides. And this is what you get. So you type in a hashtag here. It's going to be in the middle. It's going to show you all the other hashtags that this hashtag has ever been mentioned with. And the edge width is going to be a function of how many times that's happened. So Python and RStats have been mentioned several times together. Type in a different hashtag, it reruns the query, gives you a different result. Here we see data science being mentioned a lot with big data and RStats. What else we got here? Analytics being mentioned with different hashtags. So that's just a really simple, short and sweet example of how you can make an interactive visualization. And by interactive, I mean, a visualization that depends on user input. So you can show just snippets of the visualization depending on what the user asks for. And it's really, really easy with Shiny and Render vizNetwork to make these pretty good-looking visualizations that your users can change and interact with. So that is all I got on visualizations. There's definitely other visualization packages out there, but those are the three that I've worked with most frequently. And I would give vizNetwork my thumbs up is if you're looking to visualize your data or create a Shiny app with a visualization, I'd say vizNetwork is definitely the way to go. And so anyway, we only talked about visualization today, but on the RNeo4j side of things, there's definitely other stuff you can do aside from visualization. And if you want to look at the other functions that are available in RNeo4j or other types of projects that people have done with RNeo4j, first of all, you should check out the GitHub repo. That's the first link that has a README that has different examples of things you can do with the package. The second link is my blog, where I definitely do a lot of blogging on R and Neo4j. So if you're looking for more resources for examples of using R and Neo4j together. And then the last is my colleague Mark's blog. He does a lot of blogging on R and Neo4j, and is definitely a good resource if you're looking to get up and running with anything related to Neo4j or R. So you should definitely check out those links. We'll send those links out later, so you don't need to scramble or anything to get those. And lastly, if you are in the Bay Area, you should definitely consider coming to Graph Connect. It is our conference, a Neo4j conference, and it's on October 21st at Pier 27 in San Francisco. You can get everything you need to know at graphconnect.com. So if you want to meet me and talk about our stuff, or you want to meet other people using Neo4j or my colleagues, and you can learn about how people are using Neo4j in the real world, come check it out. It's usually a pretty good time. So that's all I got. I think I'm ready for questions, Greta.